For products in the particle analysis world, misconceptions can cause ripples in the purchasing process or even the usage of the equipment itself. So in this video, we're going to go over 5 misconceptions about sieves and sieve shakers. Stick around. Hey there, what's up? My name's Andrew Kotlar, and test sieves and sieve shakers have been around for a long time. When a product has been around for this long, there's going to be some things that change and some misconceptions that come along the way. And having worked in the particle analysis industry for over 110 years, we think it is important to set the record straight on the 5 of the most common misconceptions around particle size analysis equipment. So in this video, we'll go over these misconceptions. Brass sieves are better than stainless steel test sieves. Test sieves can be calibrated and repaired. Sieve shakers can be used in the production line. Sieves are FDA approved, and sieve shakers can be calibrated or certified. So, generally speaking, there's 2 types of test sieves, brass and stainless steel. Precision test sieves have been around for over 100 years, and in those 100 years, a lot has changed, especially in the resources available for manufacturing. When precision sieves started being produced, stainless steel was much more expensive and was not as readily available. So because of that, brass was far more popular. And to this day, a lot of consumers still buy brass test sieves simply because it's what they've always done. And there's also a common misconception that they're more durable and long-lasting. But the truth is, brass sieves are only slightly cheaper. And because of their properties, they'll also corrode faster and won't hold up as well as stainless steel. Stainless steel sieves are better for abrasive material and will also hold up longer in terms of the woven wire. So when it comes to sieves, stainless steel is always the better choice. Yes, you can expect to pay slightly more initially, but the wear and tear that a brass sieve will suffer will lead to higher replacement costs and a shorter lifespan in the long run. So when a test sieve is used for a long time, it may become out of spec, right? Well, the best way to find out is to have the sieve go through the certification process, where a third party will measure the openings using a traceable calibration machine. There's 3 levels of standards you can get your sieve certified to. ASTM dictates these levels, and one of them is actually named calibration grade. And that's partially where the misunderstanding happens. Even though the standard is named calibration, the standard is not actually fixing or repairing the test sieves. Calibration grade certification is a level of certification that means to verify 2 times the number of openings in a sieve. But the sieve itself is tested, not fixed or altered. The truth is, for anyone to fix a sieve, it could, in most cases, cost more than replacing the sieve. Not to mention, fixing a sieve would mean tearing the mesh from the frame, which introduces the possibility of even more errors. So you can send your test sieves in to be certified to verify they're performing up to standard, but you cannot send them in to be repaired or calibrated. Sieves and sieve shakers are designed for small samples of an entire product to be run through them. This is for the purpose of testing, not processing. Test sieves and sieve shakers are simply not intended to be used for things like processing entire material loads or placed in production lines. It's not recommended they're used this way because the lifespan of these products is estimated based on it being used for a small sample of each run, not to process every particle in your building. It's going to be incredibly expensive having these products doing this kind of work. They just simply won't hold up for that long. Sieves are intended as a method of testing or quality control and are not to be used to process entire product batches. We have a lot of customers who are in the food and beverage or pharmaceutical industries using our sieves, and it is incredibly important to know our brass and stainless steel sieves are not FDA approved. We also use epoxy and solder our sieves to hold the mesh into the metal frame, both of which are not FDA approved. So after a test is run on sieves, it is not to be added back into the batch or material load. Some companies keep that sample saved as a marker validation on the batch, and some dispose of it. Either option is acceptable, but if you're operating in a food, beverage, or pharmaceutical company, you should not add your test sample back into your production once it has been run through a sieve. Believe it or not, there's no known standards right now for sieve shakers. There's also no set specific requirements that a sieve shaker can be set to run for an industry. So the short answer is no, we do not and cannot calibrate or certify a row tap. When we have a customer who's interested in calibrating or certifying their sieve shaker, we send them our manufacturer specifications. You can make sure that your machine is running to the original specs, which will let you verify that your row tap is operating as it should be. These are the specs for the RX-29 and RX-30 row tap sieve shakers. Thanks so much for watching. If you have any questions, fill out a Contact Us form so we can answer your specific questions. Just click the link in the description. And if you'd like to learn even more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click that second link and you'll be that expert in no time. And don't forget to click the subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name's Andrew Kotlar, and I'll see you around in the next video. Bye for now.